like I said, I kind of printed off the wrong notes. So the notes that I have are completely different problems than the ones I have out here. But that is okay. I'm just going to do some of them and then I'll do some of them later. So we can use integrals to find volume of three-dimensional graphs by doing what's called a solid of revolution. And there's two different methods, and this is the disk method, and the next one we'll do the washer method. So basically what happens is, say if you have like a rectangle like this right here, okay, what happens is if I take it and I rotate it, it would look like a disc, right? Like kind of like a coin, and that's kind of what they're talking about. So it becomes a three-dimensional figure, and that's why you can find the volume. Okay. So I already have it written out for you here. So this would rotate. Okay, this would be considered the radius of that disc, and just to prove it. And I can't draw, let alone try to draw on here. Like, so this is going to be rough. My drawings on my paper are pretty good, but not here. So this is the r of x. So basically it's what it's saying, it's the radius. Okay, so in this equation where it says pi is kicked out, and this is all based off of basically that equation, the radius of this squared would be this chunk. And it's different at different parts. So that's why they put the r of x, because it's saying different x values obviously yield a different radius. So that's why you have to do it as a function and not actually straight out radius. Now we sometimes have to rotate around the y-axis. Again, I can draw this so well on my paper but not here. So we're rotating like this. This is rotating around the x-axis, so you're rotating this way. So you'd have to do it a little bit differently, and this is where you'd have to set the equation as x equals something. Okay. So first example, I already graphed it, so I'm going to cheat. Hold on. Now when I did the notes personally, I graphed it all by hand, but obviously that's not a case. So let's just do a 4x4 box here. Okay. So bear with. Okay. So this is the graph. Right here, given the information. So the red line is the y equals x plus 1, right? That's the x plus 1. The y equals 0 is here. The x equals 0 is that green line, and that's the purple line. So this is the area that we're talking about. And basically what happened is it would rotate around this x-axis, creating, and again, bear with me, a cone. So it's like at 3, right? So it becomes like this weird cone if you went like this. Okay, so it's this cone now. So we're trying to find that value, and I'm going to just go like this to hopefully help. Okay, I want to color that in. Okay, so to find this, we have to find, we have to say, okay, what's the radius? Well, this right here would be the radius of x. Well, how do you find that height? Well, that height's determined by this x plus 1. So if you plugged in 2, the height is 3. If we had another radius right here, like at 0, it would be 1 because you'd plug in that. So to find this one right here, okay, we have to say the volume equals, oops, I'm not going to write all that if it's like that. Let's go a little bit thicker. Volume equals, and they kick out pi right away, and that's fine. And that pi is because of you having a circular rotation. You need that for it. And then it says in the rules, if you're going revolution, it's whatever the function is squared. Well, the function here is x plus 1 squared dx, correct? Now you can factor this out, or FOIL this out, or you can do use substitution. I already know that you're probably going to do it this way, so I'm just going to write it. So x squared plus 2x plus 1. Now the question is, what's the bounds? Well, the bounds are going to be your x values. So from here, from -1 to 2. Because you're still rotating around the x value, you have to use your x values. So, yeah. So, pen is too thick still. So we're from -1 to 2. -1 to 2. So to go through here, and I'm sorry I changed the marker, it's probably going to bother you. We're going to integrate this so you get 1/3 x cubed plus x squared plus x, and -1 and 2. You guys know how to do this, so I'm not going to finish it. I'm just going to quickly type it in my calculator. And you can do that, so you just hit the pi, and then you go to the math thing, and you do the integrate function. So I'm just doing it this way because we know how to do it, and to save a little bit of time. Oh, guys, I goofed. Hold on. I goofed. It's from 0 in here, so it stops right here. So it's this weird cone. So that's not -1. It's 0. 0. Sorry, guys. Sorry. I forgot about this boundary right here, and it's stopping it. So it's this weird, like, flat cone without the little cylindrical part, or, like, the corner part. Okay. So I'm happy I fixed that before I typed this in. 0, comma, 2. And the decimal comes out, and you can get an exact answer, but the decimal is 27.227. All right, that's the end of the first video. Again, I'm only going to get so many parts out because I don't have these notes done. All right, see you in the next one.